So, what if I told you that the most powerful explosions in the entire universe were all powered by something, well, something incredibly small? We're about to dive into a huge cosmic secret. These tiny, superheated bubbles of plasma that just might be the secret engines behind everything from solar flares to absolutely colossal jets that dwarf entire galaxies.
You know, it's one of those huge questions in astrophysics, right? We see these events out there in space that release more energy in just a few seconds than our sun will in its entire lifetime. So, what in the world is the engine behind all that incredible power?
And here's the twist. The answer, surprisingly, isn't just hiding out in deep space. It turns out, to really understand these galactic-scale monsters, we actually have to start much, much closer to home, right on the fiery surface of our very own sun. Okay, so let's rewind the clock a bit. For over 40 years, astronomers have been staring at these colossal jets of matter and energy just blasting out from the centers of active galaxies. And the whole time, they've been stumped by one really key question.
See, these aren't just beams of light. We're talking about relativistic jets, powerful streams of plasma moving at almost the speed of light. They can stretch for millions of light years. But here's the puzzle. They shine brightest way out, far from their source. How are they releasing all that energy so deep into space?
And this is fascinating. Even way back in 1985, as this quote shows, scientists had a hunch that the simple answer just wasn't cutting it. The idea of simple, straight-moving blobs of plasma, which, yeah, they called plasmoids, it just didn't line up with the complex, knotted structures they were actually seeing.
So this kicked off a major debate in the field. Were these jets powered by those simple plasmoids, or was something more complex going on, like shock waves that were converting the jet's energy into the light we see? The big problem was, these were just theories. There was no way to actually see what was happening inside one of these jets.
And that, right there, was the roadblock. I mean, you can't exactly fly a spaceship into a galactic jet millions of light years away. To get to the bottom of this, astronomers needed to find a laboratory much, much closer to home.
And it turns out that perfect laboratory is our sun. The very same kind of violent magnetic explosions are happening right here in our own cosmic backyard, just on a scale we can actually study.
The engine behind solar flares is this incredible process called magnetic reconnection. But for years, there was this one nagging problem. All of our models of reconnection, well, they were just too slow. They couldn't explain the explosive, sudden violence of a real solar flare. Something was missing from the theory.
And then came a new idea. What if the thin sheet of electrical current where all this action happens becomes unstable and just tears? This tearing instability, as they called it, would create a whole chain of these magnetic bubbles. Yep, the plasmoids. That would act like accelerators, basically turbocharging the entire process and making it fast enough to finally explain a real flare.
And that brings us right up to the breakthrough moment. After decades of just theory, in 2024, scientists finally saw this exact process happen in real time during a solar flare. They basically caught the engine red-handed. So this is exactly what they saw. First, a current sheet stretched thin. Then it started to tear, creating a whole series of plasmoids. And then those plasmoids were violently shot out, and in that instant, boom, a massive amount of magnetic energy got converted into heat and particle acceleration. That was the flare. And get this, just to give you an idea of the power we're talking about, one of the upward-moving plasmoids they tracked was clocked at 370 kilometers per second. That is fast enough to get from New York to Los Angeles in about 11 seconds. Just incredible.
The evidence was just overwhelming. First, they got direct images of the plasmoids actually forming. Second, they saw X-ray sources at the top and bottom of the current sheet, exactly where the models said they should be. They even saw a faint X-ray source moving with the plasmoids and detected these rhythmic pulses in the signals. I mean, every single piece of data pointed to the same thing. The plasmoid engine was real.
So, now we can finally connect the dots. What we've learned from these solar storms has absolutely profound implications for that 40-year-old mystery of the giant galactic jets.
It's really all about scale. You see, the plasmoids on the sun are like a perfect proof of concept. They show us that this mechanism, this tearing instability and rapid energy release, is real. It's the same physics at play, just supersized for a galaxy.
This table really just sums it all up perfectly, doesn't it? On the left, you've got the galactic mystery, vast scales, only indirect evidence, and these purely theoretical plasmoids.
And on the right, you've got the solar solution. Much smaller, sure, but with direct imaging that confirms those plasmoids are real and they work exactly as the theories predicted.
So why does all of this matter? Well, because by finally confirming how plasmoids work, we can now better explain so much. We can explain how solar flares erupt so quickly, how particles get accelerated to nearly the speed of light, and yes, it finally gives us a concrete model for what's really happening inside those colossal jets streaming from supermassive black holes. It's a key to understanding cosmic engines everywhere. And that really leaves us with one final, awe-inspiring thought. We've just witnessed this incredible engine in miniature. So it really makes you wonder, what happens when you scale that same engine up by a factor of 1 billion? The universe just got a whole lot more interesting.